Hello, and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of interpreting exponential functions, specifically from real-world situations, and we'll do it in 5 minutes or less. So there are two main situations in which we might see exponential functions, and one of them is going to be compound interest. And so we've been learning about compound interest ever since the 7th grade. And so on the 7th and 8th grade curriculum, specifically on the STAR test, you would see this particular formula at the very bottom. It's going to say that A equals P, and then 1 plus R to the T power. So your P is your principal, and then you would have your 1 plus your rate, and then the exponent would be time, and that would be your compound interest. Well, what we do now is we look at it through an exponential lens, and you will see that it is very similar. So our basic exponential function is going to look like this: y equals ab to the x power. So how would compound interest look with both of these? Well, let's say that we're going to deposit $5,000. All right, so we'll say $5,000 principal. Now, we always need to know whether or not we are making any additional withdrawals or deposits, because then that's going to change the amount of money. So no deposits or withdrawals. And let's say we have compound interest at 5%. And then you want to know what would be a good way to calculate how much money you're going to have after X years. Well, if we were to do this with our 7th and 8th grade formula, right, well, we would say this A equals, and then the P is your principal, so 5,000. And then you would say 1 plus, and then you'd have to make sure your rate is in a decimal form. So 5% is 0.5 or 0.05. And then your t, right, would be that right there. So really it would just be 5,000 times 1.05 to the t power. So that t would be how many years? Well, that's exactly what we're doing with this exponential function right here. Right? So your a is going to be your constant, right? So your constant here is your 5,000. That's what you originally deposited, and it's not changing. It's not increasing or decreasing. Now your b is going to be your rate. Now what we need to know here is when we're dealing with compound interest, it needs to be the rate plus 1. See, they spread it out here in 7th and 8th grade, because if you just put 0.5, you're going to lose the initial amount. So this 1 captures the initial amount, and then the 0.05 beyond that shows how much extra you're getting, and then your x is going to be the years. It ends up with the same thing, so compound interest is one way to look at exponential functions. Let's look at another example. So the other way that we might use exponential functions in the real world would be population growth. So it might be bacteria, it might be some other type of animal or insect. And so what we're going to probably see is you might see a starting population. So let's say we started with 20 of whatever the animal or insect is. And then you're always going to need the rate, right? So the rate might be, let's say, 25% over each time period. And then you need a time period. So it might be months, might be years, might be days. But we'll probably just say that's going to be x, right? Because it's going to increase or decrease depending on what you want. So how would we use our exponential function for that? Well, we would say, remember, y equals abx to the x. So our a, right, is look for your constant. That's 20. Your b is going to be the rate. But remember, you need to add the 1 to keep the initial right there. So 1.25. And then the time period is going to be your exponent. And that's how we would interpret exponential functions.